This is the introduction of ECO541 statistical method. Statistics and types of statistics. The word statistics has two meanings. In the more common usage, statistics refers to numerical facts, the numbers that represent the income, for example, of a family and the age of a student. So the definition of statistics is a group of methods used to collect, analyze, present, and interpret data and to make decisions. Every day we make decisions that may be personal or business related or of some other kind. Usually these decisions are made under conditions of uncertainty. Many times, the situations or problems we face in the real world have no precise or definite solution. So the statistical methods help us make scientific and intelligent decisions in such situations. The applied statistic can be divided into two areas, descriptive statistics and inferential statistics. So we look first on the descriptive statistics. The descriptive statistics consists of methods for organizing, displaying, and describing data by using tables, graphs, and summary measures. Suppose we have information on the test scores of students enrolled in a statistics class. In statistical terminology, the whole set of numbers that represent the scores of the students is called a data set, and the score of each student is called an observation. A data set in its original form is usually very large, so consequently, such a data set is not very helpful in drawing conclusions or making decisions. So it is easier to draw conclusions from summary tables and diagrams than the original version of the data set. If we provide a table or diagram, it is easier to look on the statistic, the situation, which one is the largest, which one is the lowest, for example, by using averages. So this type of statistic is called a descriptive statistics. Meanwhile, a major portion of statistics deals with making decisions or inferences, predictions, and forecasts are about population based on results obtained from sample. For example, we make some decisions about the political views of all college and university students based on the political views of 1,000 students selected from a few college and university. So the inferential statistic consists of methods that help to make decisions or prediction about a population. For example, let's say in a class we have 30 students and we select only 15 students or the sample, which is 15, to represent the whole population. So that is inferential statistics. So talk about population and sample. What is population? Population consists of all elements, whether individuals, items, or objects, whose characteristics are being studied. So in our example just now, we have 30 students. So the whole student is 30. So that is population. You consider the whole person in a class. That population also called a target population. If we take only a portion of the population, so that one become a sample. So if I take only 15 students in my survey, so that 15 students becomes my sample. So the samples are the observation that has been selected from the population. The collection of information from the elements of population or a sample is called a survey. The purpose of conducting a sample survey is to make decisions about the corresponding population. If the survey includes every element of the target population, it is called a census. So in a class of 30 students, if I do survey on 30 students, all the students in that class, so that one becomes a census. A sample that represents the characteristics of the population as closely as possible, it is called a representative sample. A sample drawn in such a way that each element of the population has a chance of being selected is called a random sample. In the class of 30 students, if everybody has a chance to be selected in the survey, so that one becomes a random sample. So we do survey randomly. It is also known as simple random sampling or simple random sample. A sample may be selected with or without replacement. If you take 15 samples out of 30 population and one of the respondent or one of the students, after you collect the data, you want to exclude that one and replace with other students in the population, so that one is the sampling with replacement. But if you exclude that student, the 15 samples become 14 and you don't do any replacement, that one becomes sampling without replacement. Then the basic terms of the element and member. So the table 1.1 here gives information on 2007 charitable givings in millions of US dollar by 6 retail companies. We can call this group of companies a sample of 6 companies. So each company listed in this table is called an element or a member of a sample. Note that elements are also called observation units. So every element here has a data. So this data also known as observation. While the 2007 charitable givings here represent a variable. So the variable is the characteristic of companies that we are investigating or studying. A variable is a characteristic under study that assumes different values for different elements. So as you can see here, every company has different value or different element in one variable. We have only one variable here, which is the 2007 charitable givings in million dollars. In contrast to a variable, the value of a constant is fixed. So the value of a variable for the elements is called an observation or measurement, while the dataset is a collection of observations on one or more variables. So in our case just now, we only have one variable, which is 2007 charitable givings of the companies. If let's say here we have another column showing the total revenue of the company, for each company there is a revenue stated here. So we have two variables. This is one variable and the revenue is the second variable. A variable can be divided into quantitative and qualitative. The qualitative also known as categorical variable. In quantitative, we have discrete and continuous variables. The definition for quantitative variables, it is a variable that can be measured numerically. So it is called a quantitative variable, quantity, so numerical. The data collected on a quantitative variable are called quantitative data. For example, the incomes, the heights, or the total revenues, the number of houses owned, all those examples are quantitative variables because each of them can be expressed numerically. For example, how many houses you have? Let's say 3. So 3 is a numeric number, so that one becomes quantitative variable. The quantitative variables may be classified as either discrete variables or continuous variables. The discrete variables are the values that a certain quantitative variable can assume may be countable or non-countable. A variable that assumes countable value is called a discrete variable. A discrete variable can assume only certain values with no intermediate values. For example, just now, how many houses do you have? For example, 3 houses. So you cannot say you have 3.5 houses. So 3 houses is the value with no intermediate values. So that one becomes discrete variable in quantitative variables. However, the continuous variable is the variable that has interval. For example, how many marks do you obtain in the final exam? Let's say 30.5 marks. So that one become continuous variable. If the variable that cannot be measured numerically but can be divided into different categories, so that one become qualitative or categorical variables. For example, the opinion of the people or the level of satisfaction from 1 to 5 or the Likert scale from 1, strongly disagree, to strongly agree, 5. It is a categorical and also a ranking variable. So this one become a qualitative. There is no specific numerical value. So in summary, we can divide the variable into quantitative and qualitative. The quantitative, we have discrete and also continuous. If continuous, it is a numerical value with interval. For example, 4.5 kilograms. While the qualitative or categorical is the data that show the opinions of the people, the gender. The gender can be categorical data. You have male and female, two categories of data. Then the data you have cross-section, you have time series, or even a panel data. So what is cross-section data? So the data collected on different elements at the same point in time or for the same period of time are called cross-section data. This is the example. The 2010 total revenue for all the companies here. So this is called a cross-section data because you have one period here, which is 2010 for 6 companies. So that one is a cross-section data. Data collected on different elements, which is different company at the same point, 2010, in the same period. The time series data collected on the same element for the same variable at different points in time or for different period of time are called time series data. This is the example. Let's say the money recovered from healthcare fraud judgments. This data is collected for the same element, which is the money recovered from healthcare fraud judgment for the same variable at different point in time, where you have 5 different times or 5 years collection. For the panel data, if you combine the cross-section with the time series, so this is the time series, let's say for country A, and then you have the similar time series for country B, or the company A, company B, okay, for 5 years, let's say, for each company. So that one become a panel data. The data may be obtained from internal sources or external sources, or by doing a survey or experiment. Most of the times, the data comes from internal sources, such as a company's personnel files or accounting records. For example, a company that wants to forecast the future sales of its product may use the data of past periods from its records. So that company can get their own internal sources data to predict the future sales. For most studies, however, all the data that are needed are not usually available from internal sources. In such cases, we may depend on the outside sources to obtain the data or the external sources. For example, you get the data from Department of Statistics, Jabatan Statistik Negara, or Bank Negara Malaysia Data Statistics, which contains various kinds of data of Malaysia. Sometimes when we do survey, we need both internal and external data. Or sometimes the investigator may have to conduct a survey or experiment to obtain the required data. Next is the summation notation. Sometimes mathematical notation helps express a mathematical relationship concisely. This section describes the summation notation that is used to denote the sum of value, the total value. Suppose we have sample consists of 5 literary books, and the prices of these books are 175, 80, 165, 97, and 88. The variable price of a book can be denoted by X. So this is actually a price of the book, so we can denote as X. So X is our variable of interest. In mathematical notation, the prices of the 5 books can be written as follows. You have price 1, price 2, price 3 up to price 5. So X1 represent 175, X5 represent 88. Now, suppose we want to add the prices of all 5 books. So we obtain X1 plus X2 plus X3 until X5. Or X1 is 175, X2 80, and the rest. So when you sum up all these prices, you get 605. So in mathematical notation, the sigma is used to denote the sum of all values. This is the exercise. Let's say you have annual salaries in thousands of dollars for 4 workers, which are 75, 90, 125, and 61 respectively. So find summation of x and summation of x parentheses square and summation of x square. So summation of x just like the example just now. So you just sum up everything, then you get 351,000. So if summation of x or sigma x parentheses square or the square of the sum of all x values, then you have to calculate by this way. And here summation of x square is the sum of squares of x value. So every value here you have to square before you sum up, then you will get this value. This is another example. Given here the value of m and f. So compute the following summation of m. So you add everything. The first row here, you will get the value. Summation of f square, you have to put square on each number here. Then you sum up. Summation of m and f. Okay, the summation of here times the summation of f. Or by using a table, the calculation is showing here. The first column lists the values of m. So the sum of this value gives 77. The second column lists the value of f. So the sum of these columns gives 40. The third column lists the squares of the f value. For example, the first value is 25 is the square of 5. So the sum of the values in this column gives 462. The fourth column records product of the corresponding m and f value. For example, the first value 60 in this column is obtained by multiplying 12 by 5. Here the 12 and 5. And you do the same for the rest, then you get the summation of mf is 875. Next, the m values are squared and multiplied by the corresponding f values. So the resulting products denoted by m to f are recorded in the fifth column here. For example, the first value, 720, is obtained by squaring 12 and multiplying this with 5. The sum of the values in this column gives m squared f 21,145. This calculation is actually very easy if you have a software. You also can do that in the Excel by using Excel, SPSS, Minitab, eView, and any other softwares. There are so many softwares out there. For example, by using a Minitab here, you can follow the step here, or by using an Excel or SPSS, it will save a lot of time, especially if you have so many data. So our example just now only have 4 sets of data. In a real study, you have more than this. Even you have hundreds of data. So it is convenient to use a software to calculate all the values here. That's it for the chapter 1. Thank you very much. Chapter 2, we will cover how to display the data here in a diagram.